In this video, we are going over a topic of estimating a population proportion. Let's consider a problem. In a survey of 1,007 people, the report tells us that 85% of those population knows what Twitter is. The questions that we may ask them: there are about 325.7 million people in the US in the year 2017. How do we use only 1,007 respondents to reflect the whole US population? So that is the question that we are asking. So the goal in this section is to use the sample data, which is only 1,007 people, to make inferences about a big population, or we call that inferential statistics. So for this section, we focus on the use of the sample proportion to make an inference for a population proportion. The population proportion is just a parameter that describes a percentage value associated with a population. Okay, so we have the first definition for this section, which is the Point estimate. The Point estimate is a single value that is used to approximate a population parameter. We use the notation of P with the hat symbol for the sample proportion. The letter P without the hat is the population proportion. So the one with the hat is sample, the one without the hat is the population. P hat is the best point estimate of the population proportion P. And we define the P hat is the ratio of X over N, where X is the number of the subjects and N is the sample size. So let's go over the very first example. A survey conducted at a local high school found that 700 of 1,000 students use Facebook. Based on the results, find the point estimate of the proportion of all the students who use the Facebook. Now, the point estimate is the ratio of X over N, and X is 700. Here, N is the sample size, 1,000. If you take the ratio, it should be 0.7. Okay, let's move on to the topic of confidence interval, CI. A confidence interval is an interval of the numbers along with a measure of the likelihood that the interval contains the unknown parameter based on the point estimate. Alright, another definition is confidence level. The confidence level is the probability that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times, and we use the notation 1 minus alpha multiplied by 100% for the confidence interval. And we'll talk about it for alpha in the next page. Most of the common confidence levels that we have are 90%, 95%, or 99.5%. 90% in decimal is 0.90, 95% is 0.95, 99% is 0.99. Now, if we are using 90% confidence interval, then alpha is the order of 10%. So alpha is the complement of the confidence level. 90% for confidence level, your alpha is the other 10% that together they will make up a 100%. So 10% for alpha, or 0.10 in decimal. 95% confidence level, alpha is the other 5%, or 0.05 in decimal. So if you add these two values, make sure that you get 100%. 99% confidence level, your alpha is the order 1%, or 0.01 in decimal. Now alpha is the probability that the confidence interval will not contain the true parameter value. That's why it is the complement of the confidence level. So that is the probability that the confidence interval will not contain the true parameter value. So for example, alpha is 0.01, then the confidence level, we take 1, subtract that, because we are taking the complement of that, so 1 subtract that, and multiply by 100%, 99% is your confidence level. Now it tells us that if 100 different confidence intervals are constructed, each based on a different sample from the same population, then we will expect 99 of the intervals to contain the true parameter and only one not to include a parameter. So let's say we have a big population. We take 100 sample, and each of the sample we find one confidence interval, and we expect that 99 of them will contain the true parameter, and only one of them does not contain the true parameter. 95% confidence level, this one here, is the most common because it provides a good balance between precision and reliability. So we will see a lot of the problem using the 95% level. The next topic is about critical value, Z alpha over 2. Now recall that the Z score is the number of the standard deviation from the mean of data point is. Z alpha over 2. This is the value of the Z score on the standard normal distribution with the alpha over 2 area to the right. So recall that the subscript of the Z score, this represents the area to the right of that Z score. So Z alpha over 2 represent alpha over 2 area to the right of that Z score. So for example, if I write Z alpha over 2, then the area from here all the way to the right is alpha over 2. So it has the area of alpha over 2. And then Z minus Z alpha over 2, we also have the alpha over 2 area to the left because this is the minus. And then the confidence level is the area in between, or 1 minus alpha. Right? Because alpha over 2 together, they are 1 alpha. Right? And then remember, everything is 1. So to find the middle value of the area, we take 1, subtract the alpha, because the alpha is the sum of these two tails. And in the middle, of course, this is the standard normal distribution. So in the middle, the Z value is 0. Example, find the critical values Z alpha over 2 corresponding to a 95% confidence level. Alright, so how do I do this problem? Well, we know that 95% confidence level corresponds to the alpha is the order of 5%, and 5% is 0.05. And then, therefore, you can find the alpha over 2, 0.05 divided by 2, 0.025. So this is the area to the right. So Z alpha over 2 is the area to the right of the Z alpha over 2. So alpha over 2 is the area to the right of the score Z of alpha over 2. So we are looking for, what is this value Z of alpha over 2? What is this Z score that gives you the area of 0.025. Now we know that everything, the whole thing has the area of 1. Therefore, to find the area of the remaining to the left side, we take 1, subtract this value to get the left side. And now, how do I find the z-score given the area to the left? We can then use the z-score table. So let's use that. Now use the z-score table. We are looking for, remember that the z-score table only give you the area inside here from the left side of the z-score. We are looking for 0.975. Okay, 0.975. Okay, so 0.975 is right here, is the area. So how do I find the z? So we go to the left, we got 1.9. 1.9 together with 0.06 will give me 1.96. So 1.96 is the z alpha over 2. Or you can use the TI-84 or 83 to help you. We use the function called inverse num. Right, let's try that. So we are given the area, we are looking for the z-score, that is the inverse num. So we go to second distribution, inverse num, this is a normal distribution. The area we are looking for is the area 0.9750. Remember, we are using the area to the left side, not to the right, it's to the left side. So we use the area to the left side, which is 0.975. Which is right here, right? 0.975. Okay, and then we use the mean at the center, so that is 0. Remember, the standard deviation is 1 for the standard normal distribution, and we paste everything to the function of inverse num, and that will give me 1.95. Or if you round it, it is 1.96 as you saw it here. Okay, let's move on to the next topic. So we have a few critical value for the common value of 90%, 95%, and 99%. So these are the three common value of z alpha over 2 that we are using. So you can just remember these three common value, or you can just repeat the process that I showed you in the last example. Margin of error, E. Margin of error is the maximum likely difference between the observed sample proportion P hat and the true value of the population proportion. So sample, we use the notation P hat. So margin of error is the maximum likely difference between the observed sample proportion P hat and the true value of that proportion, population proportion P. And we use the formula for margin of error, E equal z alpha over 2, this is the critical value, square root of P hat Q hat over N. Q hat is the complement of P, or 1 minus P hat over N. So for example, for a 95% confidence level, alpha is 0.05. So there is a probability that of 0.05 that the sample proportion will be in error by more than the margin of error E. Now, how do I construct the confidence interval for the proportion P? So the requirements for creating a confidence interval about the sample proportion P hat of any size n from a population of size big N is that the sample is a simple random sample, or this is a subset of a statistical population in which each member of a subset has an equal probability of being chosen. So make sure that the sample is a simple random sample. It satisfies the binomial distribution. So it should have two outcomes, true or false, or success or failure. And then it's also satisfy the normal approximation to the binomial, or there are at least 5 successes and at least 5 failures. Or you can check that using this inequality. N P hat multiply 1 minus P hat, it has to be bigger than or equal to 10. If we have these 3 requirements satisfied, then we can construct the confidence interval. Take the P hat plus or minus the margin of error E. So the lower bound P hat minus E, the upper bound P hat plus E. Or if I rewrite it, remember the margin of error is Z alpha over 2 multiplied by the square root of P hat times 1 minus P hat over N, and then we change the minus to the plus side for the upper bound. Okay, let's go over the first example of how to construct the confidence interval. A Pew Research Center poll of 1,007 people randomly selected US adults so that 85% of the respondents know what Twitter is. The sample results are n equal 1,007 people. And then the point estimate the sample proportion P hat is 0.85 because we have 85%. In decimal is 0.85. First question, find the margin of error E that corresponds to the 95% confidence level. And then find the 95% confidence interval estimate of the population proportion P. And then based on the results, can we safely conclude that more than 75% of adults know what Twitter is? Okay, so let's do step by step. But before doing anything, we have to check for the 3 requirements that I mentioned before. The first requirement, make sure that it is simple random sample. Yes, this one here is a simple random sample because the poll was taken from 1,007 randomly selected US adults, so that is simple random sample. Now we check for the binomial condition. N P hat multiply 1 minus P hat. Make sure that this one is bigger than or equal to 10. The N is given here, the sample of 1,007 people. The P hat is 85%. 1 minus P hat, and this is bigger than 10, so yes. And finally, this is the binomial distribution. Why? Because we have 2 outcomes only, whether they know what is Twitter or they don't. Success or failures. So 2 outcomes only. Okay, so what's next step? To find the margin of error, remember the formula for margin of error is a Z alpha, this is the critical value of Z alpha over 2, multiply the square root of P hat 1 minus P hat all over N. So how do I find Z alpha over 2? Well, we know that for this problem, we are looking for the margin of error with the 95% confidence level. 95% confidence level means that the alpha is the order 5% or 0.05 in decimal. And then we saw from the last page, z alpha of z of alpha over 2 of the 95% confidence level is 1.96, and you can find that by finding the z of alpha over 2. Alpha is 0.025 if you divide by 2, and then we are looking for the area to the left of this value. So if you recall from the last example, we went over that, and we found that the value was 1.96. Let's quickly go over the last example here. This one here, 0.025 is the area to the right. Now we are looking for this value, so we take 1 is everything, subtract this value, we get 0.975, and that is the area to the left. And then we use this area to the left and we plug in the calculator or using the z-score table to get the value of 1.96, or inverse norm function of 1 minus 0.025. So we got the z alpha over 2, which is 1.96. We got p hat, we got p, we got n, we had everything. So now we plugged in those value in, and we got the margin of error to be this value. And the next part here, how do I find the confidence interval? Well, this is the two parameter, the population proportion. This one is between the upper bound and the lower bound. So we take the sample proportion p hat, we add the margin of error, we get the upper bound. We subtract the margin of error, we get the lower bound. And we got p hat 0.85, we got the margin of error e, so subtract that and plus that to get the middle and the to get the upper and the lower value. Or you can convert it back to percentage, move 2 places to the right, or the population proportion should be in between 82.8% and 87.2%. And then part C, they ask you, based on the results, can we safely conclude that more than 75% of adults know what Twitter is? So the answer is yes. It appears that the population proportion is a value bigger than 0.75. In fact, it should be between 0.82 and 0.87%. And then you can take a look at this picture. We know that the sample proportion is at the center 0.85, and then remember 0.0, remember for the z alpha over 2 equals z of 0.025. So that is the 0.025 area to the right, and then also the area to the left. And then the middle region is 95% for confidence level, and the lower bound is 0.828 and the upper bound is 0.872. So the conclusion is we are 95% confident that the proportion of the adults who know Twitter is between 0.828 and 0.872. So we are 95% confident that the proportion of the adults who know Twitter is between these two values inside the 95% confidence level. Okay, the next topic is about determining the sample size. Now, how many sample units n must be obtained? So that is the good question. Before we collect the data, we should estimate what is the good amount of n, what is the good amount of the sample size we should have in order to get a good value, a good outcomes. So when an estimate p hat is null, then n is found by the formula, the critical value z alpha over 2 square multiply p hat q hat. Q hat is 1 minus p hat, the complement of p, and then over the margin of error square. And when the p hat is unknown, or when you have no estimate of p hat, then p hat and q hat multiply together, it should be 0.25. So if p hat is not given, we assume p hat is 0.5, q hat is also 0.5, so their product is 0.25. Now the round up rule, always round n up to the next larger whole number if n is not a whole number. So pay attention to this clearly. Alright, let's go over the next example. Gap, Banana Republic, J. Crew, Yahoo, and American Online are just a few of the many companies interested in knowing the percentage of adults who buy clothing online. How many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? So you don't want the margin of error to be bigger than 3%, and 3% of margin of error in decimal is 0.03. And then using this recent results from the census survey, we know that 66% of adults buy clothing online. So let's try that for part A. So for part A, we know that 66% of the adults buy clothing online, or 0.66, and that is the amount of the point estimate of the sample proportion of p hat. And in this case, we do have some information for p hat. If we do know some information for p hat, we should use this rule: z alpha over 2 square p hat q hat over e square. Okay, q hat is 1 minus p hat, which is 0.34, and then again this is 95% confident interval, and that gives me alpha to be 0.5, 0.05, alpha over 2 0.025, and we saw earlier the value is 1.96 for z alpha over 2. This is the common value, and therefore you can find the sample size z alpha over 2 1.96 square. P hat is given 0.66, q hat we just found here 0.34 over the margin of error 0.03 square, because you don't want to get no more than 3 percentage point, or 3% or 0.03, and then round up to the next whole value, or 958 people for the sample size. Okay, next question. Next question is B. Assume that we have no prior information suggesting a possible value of proportion. So now, if we don't know any prior information, p hat is unknown, then n is found by z alpha over 2 square multiplied by 0.25 or over e square. So again, this is the formula, e square. We got z alpha over 2 again 1.86, 0.25 for the p hat and q hat, because we assume each has 0.5, and then e is again 0.03 square, and that should be 0.1067.11, and round up to the next whole value, which is 1068. Again, if the p hat is unknown, then we assume p hat is 0.5 and q hat is also 0.5. Okay, so that is about the sample size. Now, finding the point estimate and the margin of error E from a confidence interval. Okay, so given the upper confidence interval and the lower confidence interval limit, we can also be able to find the point estimate p-hat or the sample proportion and also the margin error. To find the p-hat, we take the upper confidence interval limit, we add to the lower limit, we divide by 2. But for the margin error, we take the upper minus the lower and then divide by 2. So those are the two formulas you should also know. Okay, so the last part of this section is how do I use the TI-84 to perform the analysis. Again, let's consider back to the sample that we went over. A Pew Research Center poll of 1,007 people randomly selected US adults so that 85% of the respondents know what Twitter is. The sample results are n equal 1,007 and p-hat, the point estimate is 0.85% or 0.85. Find the 95% confidence interval estimate of the population proportion P. Now, we can also find the confidence interval directly on TI-84, and let me show you how to do that. Okay, so first thing, you're gonna go to Start, turn on. Now we go to the Start button. We are looking for the confidence interval, so we go all the way to Test, and then we move down to one proportion Z test. Sorry, Z interval. So do not confuse. We have a similar option. This is one proportion. One proportion Z test is not correct. We are looking for confidence interval. So we are looking for one proportion Z interval. Okay. Z stands for the standard normal distribution, and we are looking for the proportion interval, the interval of the proportion. And this is one sample only, so 1. So we hit enter. The x value is the number observed. In this case, the number of the observed A56, and n is the sample size 1,000, 1,007. Why do I know the number observed is A56? Well, because I know that 85% of them know what Twitter is, right? So that is the number of the people observed who knows what Twitter is, and 0.85%, or if you find 85% of 1,000 and 7, you should get A55. We round up to A56. Okay, so that's how we found the number of the observed. Okay, let's go back to Start, Test, one proportion Z interval here. Right, we know that C level is 0.95 because you want 95% confidence level, and then hit calculate, and then you got what? You got the answer. This is the lower limit, this is the upper limit, and that was the one that we got earlier here, 0.828 here, and 0.8721 right here. Okay, so this is lower, upper, the same thing as we got earlier, but now we just use a few clicks on here and we can get that. It's straightforward. Okay, so that's how we apply the TI-84 to find the confidence interval for the sample proportion.